observer is one of the most essential design patterns in JavaScript, and it makes sure that when a user interacts with, well, a page, like clicks a button, that some things actually happens. It allows some code to happen when there is some interaction with the page, and even more. This is the first design pattern that I've learned to made myself about probably 20 years ago when I started coding, and I still love it. And you might be tempted to skip this module because you have seen it so many times, but we are actually going to build Observer ourselves and learn how it actually works internally and how it can be used other places in our code and not just user interaction. It is so useful to master that you will probably use it in many other programming languages in your career as well. Now, easiest example to recognize this pattern is, well, click on a button, where we click on this button and it will generate or send a click event. We can pretend that the button is generating many click events because somewhere in our code we could be listening to this click event and reacting to it. We can submit the form or maybe send some request to the backend, do validation or whatnot. The button is the event source, the click itself is the event being sent, and our code that observes for the event is called, well, the observer. But what is cool is that we can attach many pieces of code to this event and they will all react to the same event. But this pattern is used more than just the user interactions. When application grows, especially if it's going to be particularly a single page application, we will have a lot of modules talking with each other. Say we have HTTP, validation, notification, log, UI and security modules. How will they be connected with each other? We would have to hard-code some security check on each and every HTTP call, and then do some notification for the user, some change in UI, and log something to our login service. Now, hard-coding everything with everything already sounds like a complete mess to maintain. And what if we remove one module or want to replace it? We would have to change every other possible place where this, for example, log is being used, and that will be pretty much every file in our application. This is where Observer Design Pattern comes in and solves this quite elegantly. This pattern is suitable when the total number of involved objects might not be known in the start or might change underway. It is very beneficial for decoupling components from their objects. And you will probably use logging for every module in your application. But number of your modules will change over time. And if you ever want to replace your logging module, this pattern will save you a ton of time because login would not be coupled with each and every other module if you use Observer. Also, pattern is almost always used for bigger application as it allows us to extend application's functionality without changing the source code, like a plugin. And the way we do that is we listen to some events like a before run application or maybe after user is deleted or after an order has been placed. And we can just run our custom code, our custom plugin that subscribes to that event. And you will actually do this yourself in the Skill Builder lesson, as that is the best way to learn by far, by actually doing yourself. Its biggest advantage is clear separation of code and dependencies between modules. One module can communicate with one or practically unlimited number of other modules without actually knowing that. And the code will never break if we remove one of those modules. So one part of our application is not even aware of any other parts in the code. This makes developing and debugging very easy, when used correctly, of course, because our code is very decoupled, it's very separated. We're also following the good practice of open solid principles. One of the solid design principles, and this principle states that software entities should be open for extension, but closed for modification, meaning that we can extend functionality of our application without actually changing its code, and we will see how this works later. Now, nothing in life comes for free, so this pattern has some troubles as well, and most relevant is the control of the order of execution, at least in my experience. The JavaScript in a browser runs as a single thread, meaning our listeners will not execute in parallel, but in the order they are subscribed to. And their time of execution could be different as well. And that is not always easy to control and predict for and account for, especially with dynamically assigned subscribers. So if not careful, we can end up in a situation where we would submit a form and then do the validation after it has already been sent to the backend. Now, another concern is that it's easy to go overboard with this. And if we use this design pattern for everything, the code becomes really hard to predict and hard to read, because events could be located any place in our code, and when we open our observer class, we actually cannot see any connections. We have no idea what could be triggering some unexpected behavior. So like any design pattern or anything in life, it cannot be used for everything. Also, the subscription is not managed properly until its life cycle, end of life cycle. So meaning it's not unsubscribed properly at the end. There could be a memory leak, which is very noticeable once your application starts to grow, especially if you have multiple components on the same page, and especially if you are building a single page application. Just a small disclaimer here. I might use terms subject and publisher and observer and subscriber kind of interchangeably here, depending of what I'm explaining. Just know that there is a pub-sub or publisher-subscriber design pattern as well, which is similar to observer pattern, but the pub-sub is even more isolated and is generally used between multiple applications. Let's look at one real-life problem that observer pattern solves. This here is a typical CMS functionality or content management system, or maybe a blog functionality, where the content has been published on the website. And when that happens, we need to somehow send a notification to our members. Rather than having users to automatically click on a button, we want to automate that. Also, we need to update the sitemap file for the SEO, search engine optimization, and we need to update the cache of our website with that new content so that the website remains relatively fast. How can we solve this? First, here I have the blog post publisher, which has methods like publish post, update post. Then there is notification service, which can notify our users. And there is a sitemap service and the cache refresher service. And we are just calling it down here so that when I run this code, we get here notification that the post has been published, notification of members about new post has been sent. There is updating sitemap and refreshing the cache. And the way we are doing this is basically by here in the controller just calling whatever needs to happen, right? So the blog is being published, and then we are notifying users, and then we are updating the sitemap, and then we are refreshing the cache from our main controller file. And this is fine until we suddenly need to update the post some other place. Maybe it's a cron, maybe it's a scheduled post that is going to come, let's say, tomorrow morning at 7 when everybody's going to work, and we need then to basically notify the blog publisher and update sitemap because we don't want our article to be available to Google before our members get it. And also we need to refresh the cache. So we basically need to copy all this code some other place again. And then this is when we are creating the blog post, but a bit later we might have to update the blog post. And when we update the blog post, we again need to copy all this functionality. So this is a duplication of this exact same code here. And then later, when we are to delete the post, we maybe need to do the same thing again. This time we are not notifying users, but maybe we're notifying admins that a blog post has been deleted. While this might work great, you probably see the problem here. We have a lot of duplication here. And at one point, if we need to change the way sitemap is being updated, let's say that we need to pass in the blog data and then the title of the blog post, or the URL or the ID or something like that, we need to remember to find each and every instance of this update map and then to pass it in and then to find it again and pass it in. And chances are that sooner or later we are going to forget some place where this duplication needs to be, where this change needs to be done. What else do we have? Instead of duplicating here, what can we do? Well, we could just do the easy way and just take all this code here and move it right after the blog post has been published. We can just call the notification service and sitemap and just call it from there. But this, if you think about it, has similar problems and it might be even worse than before because we now need to do the same in the updating the post and then when we have the delete post, right? But also the publish post and the update post now do much more than one thing they are designed to do. They're not just worrying about actually publishing the post and updating the post, but they're also maintaining other things. They're worrying about notification, about cache and sitemap, and a lot of things that this method should not worry about. There's also dependencies here, which means that this blog post publisher cannot be moved from this system anywhere because dependencies are following with. And as mentioned, the single responsibility principle here is broken. It's not implemented because there is no single reason for this method or this entity to change. The single responsibility principle is the first rule of 5 solid design principles, which says that, as we mentioned, the method and the object should have only one reason to change, thus having only one responsibility. In this case, dealing with blog posts and nothing else, no notification, no cache, no nothing else. So this solution also makes our blog post very tied to these other objects, and it also makes our blog post very difficult to test because it suddenly depends on many other things. We cannot reuse it in any other application. So our code is not flexible, and this is how problems begin, especially when there is a bug introduced somewhere in one of these steps and you don't know why the blog is not publishing anymore. Is it because the cache cannot update the files, or there is notification problems or sitemap problems or something like that? This is clearly a no-no, and I hope that you're not writing applications like this. But I want you to pause this course here and think, how would you solve this problem here so that publishing a blog post also sends notification, updates sitemap, refreshes the cache without calling these 3 objects, either here from the actual publish method, but also without using this code here in this controller or some other controllers or some other main files where they risk a chance of being duplicated. And there is also one cool feature that I will show you later, and that is that we can completely delete the cache refresher programmatically, and we can turn off notification for this cache refresher for updating cache without hard coding anything. Try to figure out some solution, and then I will show you one way of solving this. Let's see the theory behind the observer design pattern, how it actually works, well, conceptually, and what problems does it solve. So in our previous example, we had 6 modules that need to cooperate. So if we call one module from the other, we can quickly see how we are coupling them very tightly, meaning that one module will depend on some other module, and it won't take long before all this becomes a mess. But also, what happens when we remove one of these modules? How will our code behave? Sometimes we just have to remove some module by design. We have the need to do that. It's a requirement. So it becomes a bit tricky to have modules cooperate and yet have them completely separated in a way that they should not be aware of each other and they should not care if other modules exist. This is exactly what observer pattern solves for us. It allows us to have a module like this HTTP module or a functionality. When I say module, I don't think necessarily module design pattern, right? It's a part of the application. But it allows us to have this HTTP notify all other modules that something is happening. Either if some HTTP value has changed or some event has happened, so that the HTTP module will act as a subject. And the name subject is something we use in the observer pattern to specify an object or a module that is emitting an event. And it's notifying all other observers. And it also means that it is as a subject being observed by other patterns, right? Thus the observer pattern, observed by other modules. And all other modules only need to subscribe to this subject to some type of event, let's say post request success or post request error maybe. And then when an error in the post request happens,
The HTTP module, which is a subject, will then notify all other observers who are interested in that event, all other subscribers who are interested in that event, that there has been an error, and they will know what to do with that information. If all this is a bit fuzzy, do not worry, we will build one observer soon from scratch, and then it will be much clearer how all this works. Also, in the skill builder lesson, you will make one observer yourself so that you understand it on a much deeper and personal level. But the beauty is that the observer pattern here can subscribe to different events from the same module or even from different subjects. In this case, the notification is listening to HTTP as a subject, but also it's listening to some user interface events as a subject. But we can make it even more interesting in a sense that one subject, in this case HTTP, can also subscribe to some other subjects like this subject 3 from the user interface. So it will be a subject its own. Here I have drawn this subject box outside of HTTP, but you can think of HTTP as a subject being observed by notification, and at the same time HTTP module is observing the subject being emitted from this user interface, or the events being emitted from the user interface subject. So when a person clicks on something, the HTTP request will have some obligations to do something, some action it will do. And I understand that this looks now maybe a bit more chaotic than with the first slide when we started. But if you look closely here, you can notice that none of these arrows connect modules directly. So none of these modules are connected to each other. They are all connected via this subject additional layer in between, which means that even if we replace one entity, for example, if we would to remove this log module now, everything will work just fine because they are all still connected only to subjects and not directly to each other via code. They are only connected to each other via the observer pattern. And this makes this pattern very useful in applications where we might have different modules loaded at different time. We could even load these modules dynamically in the runtime, or maybe for different types of users, or maybe users want to turn on or turn off something along the way while the application is running, right? Maybe they want to turn and change the way they are notified. Or even sometimes we might to completely uninstall a new module, like this log module here, or add a new module, right? And that involves physically adding or physically removing files from our application. And we can do so just fine with the observer design pattern, and everything will work just fine. And this means that our modules are loosely coupled. They are not tightly coupled, meaning that none of our modules actually even know that there are any modules in the system, which makes it very easy to remove and add new modules into the system without the need to change anything. And if you have ever written any plugin for any application, you probably used the observe pattern in a sense. So important concepts to remember here are the subject, that actually in this case is HTTP, so it is a subject. I have just visually drawn it here outside of this box. I could have just put a label here, but it's a bit difficult to explain what it means. But the subject tracks the internal state of the events and then informs all the modules that are interested in those changes that, well, a change has happened, that an event has happened. And the observer is the name of the entity that is interested in observing those changes from the subject, right? So the observer subscribes or registers, or it observes the subject to get notifications about changes, and it can do some external code, internal action when such event happens. Let's solve our problem of the blog post which needs to somehow notify other modules that one article has been published or updated. And here I will implement simple version of the observer, and then we will go through the entire code to see what's actually happening. So please just follow the implementation first, and then I will walk you through the new code afterwards. So let me just clean up our examples here that we don't actually need. And now we are back to the original code. And for the observer pattern, we need two things. First is a subject that's going to be observed, and it needs to keep track of the state. In this case, this is the blog post publisher, that is the subject, that somebody is going to observe that. Now, for subject to know who is observing it, it needs a place to store those subscribers, those observers. So what I'm going to add here in the constructor is one array that is going to store all the observers here. We also need a method to add observers to this array. So I'll just call it subscribe, which is going to push new objects to this observer. Since I'm here, I'm also going to put a method that's called unsubscribed, which is going to remove these observers from here. And I'm going to use filter for this, which will just basically remove passed observer to the unsubscribe. And I will talk a bit why the unsubscribe is important. So now what we have done is we have added a place where observers of this subject, of this blog post publisher, are going to live, are going to be. And then we need a method that will actually notify all these observers that a post has been published. So here, before return, we are going to call all the observers or just notify all the observers. And we will do that by calling this notify observers method, which I haven't made yet, but we are gonna make it right here. And notify observers will take in some data. In this case, this could be a post, but it could be much more complex. This is just a simple example. And what it will do is it will go for each, and for each observer or subscriber, I'm using the observer and subscriber here independently. Maybe we should just stick for the observer for the sake of this tutorial. But if I say subscriber, I mean the same thing. And then we are going to call observer, let's call it observer notify. Now, what this means is that each time we are going to notify observers that a blog has been published, this method notify will be called, which means that if our notification service, actually let's call this one on update, that's much more easier to work with, and it signifies that this should be called on update actually. And this means that when the notification service on update method is being called, we are going to say that notification update just for the test. Now I will just connect them and show you how they're connected, and then we will go through the code to see what's happening. So for this to work, we need to inform our blog post that a notification service should observe the update method. So what we do is we can move this notification service a bit up, and then here we need to say that blog post publisher subscribe. And in this subscribe, we are going to pass in the blog notifier. Let's just run this for the fun of it, just to see what will happen. And we can see that we actually have this new notification update here on line 30. And that is our new method here, notification update. Now we still call this blog notify. So let's remove that one. Actually, let me comment all these so we are not confused by them. Now, if I were to run this, we can see that there is a new post created and there is a notification update. So let's look at a code briefly, just how this works, and then we can continue connecting all this. So what is happening here is that when here we run new notification service, we are just creating an object. There is nothing fancy with it. Let me open this side by side so we can actually see it a bit better. So now when we create blog post new publisher, in the blog post publisher we are actually creating this observers here. So this new will actually create this array. That is fine. When we then call subscribe, we are actually giving in this blog notifier. So this blog notifier will get pushed into these observers. I will just put it in blue so we can follow. So this blog notifier gets into these observers here, into this variable. And that is important because once this publish post here gets triggered, it is going to actually call this method publish post, which is fine. But then this notify observers from here will call this method here. And that means that for each observer, it's going to call the onUpdate method. So this onUpdate method is crucial here. And why is that important? Because in our notification service, onUpdate will actually console log notification update. Now, if this is first time you're seeing observers, you're probably thinking, what in the world is this creepy bald guy talking about on YouTube, and why should I do this so complex, because when I can just call one line of code. This is where things get cool now. This onUpdate will then call notify, this notify method, which is going to actually notify members about new post. So if we run this now, there is a problem with title. That is because we are passing the wrong data and we are not passing this into notify. Let's try one more time. Now we can see that post has been published, but also we are notifying members about new post. If we look at the code carefully now, we can see that blog post publisher is only receiving this blog notifier programmatically here. But other than that, we are not calling the blog notifier here in the controller. And we are also, if you remember carefully, we are not calling it any place here. There is no trace of our blog notifier in our code. There's only two instances found. One is here when it's passed in, and the other one is here when it's created, which means that our blog post publisher is never in touch with the notification service. Let's make this a bit complex, because now hopefully you will see why this is even cooler. If we move this sitemap here and cache refresher here, so here we have creation of our objects, and here we have subscribing, we can now subscribe with the sitemap updater and cache refresher. And if you remember, we just need to have this update method in the sitemap and in the cache refresher. This one will call sitemap, obviously. And this one will just call the refresh method. If we run this with a bit of luck, we can see that post has been published and the notification has been sent to members about new post. There is also update of the sitemap, and there is also refreshing of the cache. Let me go over the code one more time, just so that we are on the same page of how this works. So this is now the same file I'm opening now on two sides here, so that we can follow what's happening. So we are just creating blog notifier and notification service, and that's fine, nothing spectacular there. Then we are subscribing to the blog post publisher with notifier, sitemap, and cache refresher. When we call this subscribe, let me find this blog notifier. Again, this is the exact same file. I'm looking at the right side, so don't be confused. We're just using it so that I don't have to scroll so many times. When we call this subscribe, we are adding these observers into this observers variable here, property. So that when we publish a post, we call this method here, which in return calls notify observers, which in return calls each of its own observers and calls the onUpdate method on each and every one of them. In this case, we have three here. So these are the observers which are lying into this observer property here. So these three here are inside these observers. Why is that important? Because now for our notification service, onUpdate is going to call onNotify. So this is this notify. So we are notifying members about new post. The sitemap is going to call also onUpdate, and it's going to update our sitemap. And if you remember, in our update sitemap, there is updating of the sitemap actually. And in our cache refresher now, this onUpdate is going to call this onRefresh, which is going to refresh the cache. So if we look carefully again at it, there is no place where we are actually calling the sitemap refresh and cache clean and notification send notification. We are just subscribing to the blog publisher, which is then sending an event that the blog has been created. And then on that event, in this case on update, all of our methods know what they should do. All of our listeners or all of our subscribers will get notified and they will do their own thing, like notifying members about the post, updating sitemap, and refreshing cache, just like we see here in the browser. We are notifying, updating sitemap, and refreshing cache, right? Now this looks much cleaner and it's actually much easier to work with because, again, we are not calling these methods directly. We are just attaching them to different events, which means that now, if we go into our blog post publisher, we can have another notify observers when the post has been updated, so that when we update the post, the same observers will be updated about this change. In a bit more complex system, we are going to have here, and this is what you're going to do in the skill builder lesson, is that we are going to have the update event passed in, and here we are going to have the create event, so that you can here identify which event do you actually want to work with and whether you should notify members. If it's an update, maybe there is no need to notify your members, but you definitely want to notify them when you create a new blog post. So instead of us manually calling from here or from the controller what we think should happen, in this case, blog post publisher does not care about who is observing its behavior and what are the observers going to do with that behavior, with that information. It is just notifying observers, and it's up to the observers to figure out whether they should react to this event and then how they should react to this event. And this is very easy because it makes code clean, and our publisher, blog post publisher, actually does not care about anything else. It's only worrying about its own thing here, publishing posts, right? And while this is relatively simple, it is at the same time a bit tricky design pattern to implement, especially if you've never worked with it. That's why it's important that you try to do this yourself in the skill builder module of this course. In essence, it is just the subject is letting its subscribers know that there has been a change. It's just notifying its observers, and the observers are reacting to that change. That is all that is happening here. Now, the cool thing here is that even though I've written this here in the code, here in subscribing, this could very well be in a database or in a user interface where somebody in the administration or in a profile page maybe goes and picks whether some things should be applied, what should be applied here. And then from the database, we are just going to make one for each, one loop here, and subscribe to our events dynamically. You can just let certain users receive notification and certain users don't receive notification. And one even cooler example here is that we could have a before delete, for example. Here we could have one delete post, which is just deleting the post, right? But here we could have a if on this event, and here we could say this notify observers, and if any of the observers returns false, we can prevent post from deleting. Maybe you're making a custom plugin for this application, or maybe you do need to clean up something before post is deleted. Let's say if there is a comment, you should not be able to delete posts. So you could have a plugin that is actually preventing deleting of these posts here. It's a very cool way of controlling your application and very cool way of extending functionality. And this is one of the biggest patterns that changed the way I was coding, at least when I figured it out and when I first learned about it. Because this subscription management, again, could be a dynamic from database, or even user, as I mentioned, could check it somewhere in the user interface to customize this functionality, which means that you can just install plugin with a file, and then when you physically remove the file, the application will figure that one out because it's going for each in every folder, and it will just unsubscribe and nothing will break if you delete a file from your application. That is one of the main advantages and main benefits, that we do not need to hard-code dependencies between modules. We can set them up dynamically on the runtime from the database or from the user interface. So let's quickly run through this code one more time. What is happening here at the bottom when we are initiating these objects? It's just a simple initiation. There is nothing special here. When we are subscribing to this blog post publisher, we are actually passing in who is interested in these changes that this blog post publisher might have. So in this case, we have blog notifier, sitemap update, and cache refresher, which means that they are being added to this observer array. It also means that when we publish a post, we are just notifying each and every observer and calling the onUpdate method on each and every one of them, which will then in turn send a notification here, right? And it will update sitemap because this one will react like this. And in the cache will be refreshed here. Now, this is very cool functionality. I did promise you that there is this unsubscribe method, and it's very important that you unsubscribe once this blog post publisher is not relevant anymore, or once these observers are not interested in these events anymore, because you could be stuck in a loop and you could create several post-blog publisher objects at one point, maybe by accident, and they will live in memory and they will still call observers. So if you have two blog post publishers publishing post, which is not that likely that it will happen, but it can happen with some different examples, you will have double call on each and every subscriber of it. So it means that you will send two notifications, you will send two sitemap updates and refresh cache 2 times, which is not that dangerous. But if you make it 5 times or 10 times, and this is very important with React or Angular or single page applications, where a single page could load multiple times, but never be deleted from the memory. So it's just a thing to be careful about. Now, I hope that you understood this, and make sure to visit the skill builder lesson so that you can actually build one example yourself and learn this really good. Let's look into a few real-life examples of libraries and applications using this design pattern so that we can actually see how others are using Observer. Here I have Rocket Chat, which is a platform that you can truly trust according to their creators. It puts data protection first. And here on their GitHub, I have found in its source this example, a few instances of them using observer pattern. Here in the UI, for example, in this on-toggled features TypeScript, this is TypeScript, but it's the same principles. There is actually this observer that will observe some functionality of some query keys, and then subscription. We can see that if the result is not success, it will actually prevent this subscription of running, and on keys down and keys up, it will react to this element on toggle feature and basically make sure that everyone involved gets these subscriptions. One of the popular libraries for React is this Redux, and what it does, it holds the entire state of your application. So it's centralized place where it's maintaining the state of your application so that different components on the page, for example, can send and update their new state. So you could have two maybe login buttons or two confirm buttons or something like that, and they will communicate with each other via this Redux centralized state. So it allows you to pass data between many different components at the same time. It has a concept of a store, and changes on these entities in the store are observed via observer, or at least very similar pattern as observer pattern, because it's much more complex. Obviously in the Redux, it's a very big library. So here in these examples, we have an event that's being sent. In this case, it's an actual object that's being sent of type add to do. And that event is what would be dispatched. That's similar to what I've showed you with object created or blog post created or blog post deleted. But here, these events would get dispatched to this with this add to do and with some text in addition, so that your application can then listen to these events of type add to do and get this text for this add to do here. Here we have a listener, which will then invoke anytime an action has been dispatched, right? And you can read more about how these reducer works. But it's important that we see that there is a subscription going on, just like we did it. And then there is this change that needs to be handled, right, when this store changes. So it's a bit different, but it's similar principles. And they also have the unsubscribed, which is very important because you don't want this running multiple times in case a user goes back and forth between two pages. And again, this is a similar thing that you're going to work yourself in the skill builder module later, where you will practice hands-on how to build this, where we will work with the before start and after start and how to react to them, to those events, similarly to what they have here, where they can have different types of events. Then let's look at Angular, which is famously popular for using observables. It actually uses RxJS a lot internally, especially for the observer type pattern. And this RxJS is a popular library on its own, and I've used it quite a lot, but its sole purpose is of using this observer pattern. It's a much more complex in Angular, but I've been using it for several years, and it works very good once you master and you start thinking in the ways of observable. But the simplest example they have here is this using the RxJS with a method off, and this off method can make anything into an observable, so that these numbers then becomes, well, observable, something that you can observe. And when you subscribe to these numbers, in this case, you can just subscribe with an anonymous function here. But when something changes, it will just call this method here. So that if you, let me find the example, if you just iterate through them, it will just call your console log and it will just put in all the elements here. But if you would to change this, multiply it to 1 and 2 and 3 with some other number, the observers would react instantly. As soon as you touch one of these arrays here, this next method, which is in our case on update, would trigger, and every observer would then react to it and get new values here. So if you ever come across Angular framework, this is a very crucial concept to master, and it's used on a very advanced level. It's a very powerful, it has some gotchas as I mentioned, but it's a very, very good thing to learn.
Let's do a quick summary and repetition of what the observer pattern is, so that you learn the most and get most out of this course. You can use the printed worksheet for this lesson, or use the quiz module as well on the platform itself to test yourself on the knowledge on these design patterns. Make sure that what you learned here actually sticks long term. You can read about riding a bicycle as much as you wish. Unless you do it, you will probably not learn it. So the observer pattern is very important in JavaScript and in programming, but in JavaScript it's used a lot. Do you remember when it's used maybe in the UI? Let's say there is a button. Do you remember how observer could be used here? When somebody clicks a button, the browser sends an event to all observers of that event, of that click. That's how we connect our code, basically, using things like onClick or add event listener. And the same goes for the other user-driven events like key down scroll and input and something like that. Now, under the hood, these are all based on the observer pattern. More or less, they work the same. Something happens somewhere and the subscribed listeners are notified. But this idea goes beyond user input, as we talked. It can also be used for programmatic communication inside our applications. It doesn't have to be user interaction. Do you remember how observer is used for HTTP request? HTTP could be broadcasting events like, do you remember which one? It could broadcast in progress, success, error network, fail, completed. In the next lesson, in the video builder, we will work on observing application lifecycle events like on init, before login, after validation. So anytime we subscribe to be notified when something is happened, we have interest in some event happening, which is not asynchronous. We don't know when it's gonna happen, right? At that point, we are applying the observer pattern, or at least observer pattern-like thinking, whether it's user input, async data, or application state transitions or something. But do you remember from our theoretical case how many subjects can one observer have? We said that one observer could have many unlimited subjects, and one subject could also be observed by multiple observers, right? We talked how observer allows us to even turn off some functionality programmatically, like removing some plugins or maybe uninstalling plugins from the application and physically removing its files, and everything will just continue working. But do you remember the biggest advantages or biggest pros of this design pattern? We just said that components are decoupled, as observers can subscribe to and react to events without any code added to the subject, meaning that either observer or the subject actually need to know about each other in order to cooperate and share data, and list not in the code base. They can be introduced to each other in the actual runtime, right? We also talked about modularity. It's similar to module pattern, but this is not the module pattern. This makes the application easier to extend and maintain. It's easier to test smaller parts of the application that are not depending on anything else, basically. We also talked about one of solid principles, the open-closed principle. Do you remember what that means? It means that application is open for expansion, for adding new functionality, but it's closed for modification of its code, meaning that we can again add new functionality without modifying the existing code, which is great if this source of the application could update and our changes are not affected because they are in different files, basically. But it has some disadvantages. Do you remember some of the cons, some of the biggest disadvantages we mentioned before? We said one is the execution order, which comes to my mind when I think of this pattern. Sometimes the order of subscription is not easily determined by just looking at the code, and subscribers could come maybe from database, like application plugins. So it's a bit difficult to say which module which will run first, and that is important if we need to do, say, validation first and then submitting the form afterwards. The second disadvantage is overuse. We talked about, well, potential of overuse. Overusing this pattern makes debugging even more difficult because components are so isolated that if we just look at the code, we probably have no idea which code, which module will running, and especially in which order, right? So debugging individual component is easier, but debugging entire application could be tricky. We also talked if you don't unsubscribe from an event. Do you remember what is gonna happen then? We will get some memory leaks, right? Because improper handling of subscription can lead to memory leaks, particularly in larger applications. And this is where it's important that all subscriptions are removed when they're not relevant anymore, when the component or the page is not visible anymore. This is especially notable in single-page applications. You will reach that problem very fast if you're using single-page applications. Because the page is not being refreshed by design, basically. All the components are living, they're just hidden here. So understanding and applying this pattern is beneficial across different programming languages as well. So learning this now will benefit you later in your career, I promise you. Majority of senior programmers know more than one programming language, so it's important to know these design patterns that apply across different languages.